So I didn't get any, I don't think I got any emails from you guys about difficulty downloading it. So I think that's a good sign. So here we are. When you open it up, you should get a window that looks like this. This little purple square is what we call a command line. It's not really commands as much as this is where we're going to put the mathematics, right? This is a mathematics line, okay? So the first thing you can do is you can just use this as a really powerful just computational calculator. So you can do something like 30 plus 5.2, and then you can, if you highlight, you can highlight things. So if I highlight that and just hit left parenthesis, it automatically puts both parentheses. It's got all the common symbols built in, so I could say like times E. So E is there 2.8, 2.7, 1828, etc. If you want powers, so square and cubed are built in. You just hit Shift 2, and that automatically does square. Shift 3 does cube. Any other exponent, you're going to do Shift 6, and that's your caret. So now if let's say I want to take that whole thing, I want to put parentheses around that, I would take that whole thing to the 1.5. So if you do Shift 6, you get that little question mark, then 1.5. And notice, as long as you have a valid expression, it's always giving you the current value of the current. So as I was doing that, it was always updating the value. You don't have to hit enter to get the value. It just always, whenever you have a valid expression there, it'll just show you what that is. Okay? So square root, so I can highlight the whole thing. For Mac users, it's Option V. So if I do Option V, it just automatically does square root. For PC units, PC users, I think it's Control Shift R. Try that.
Yes.
Hey, I know something. Okay. So, and then what's really nice about this is, say I just want to divide this e squared by something. So you can highlight it and then just hit divided by, and it automatically gives you, and it will do division vertically, which is really nice for looking at your expression and editing it, rather than in a regular calculator having to do everything horizontally with lots of parentheses. So I can start new parentheses. So all you need for parentheses is just the left parenthesis, and it gives you both. So then I can do, if you want pi, you just type pi. So pi plus 3 times, say, 5 to the 0.6. And so here I've landed on this value of 10.7. To get a new command line, you can, for Mac, it's going to be Command Enter, and for PC, it's going to be Control Enter, and that gives you a new command line. Now you can, like a word processor, you can copy and paste. So say I just want this part right here, so I can copy that and then paste it down here, and immediately it gives me the current value of that expression. So copy and paste is really helpful. Cut and cuts, right? Cut, copy, paste. Let's see, what else? We got pi, we got e, we got square root, exponents, division. I think that's the basics for calculating. So that's really helpful. When you, so now in terms of graphing, my video is running in the background there. So what prompts GC that you want to display a graph? Well, X or Y. So X stands for the x-axis, or all values on the x-axis. Y stands for all values on the y-axis, or Y. So if we want, so if I do, Y equals 3, what is that? So that's just a mathematical statement, and now graphing calculator is going to display that mathematical statement, which will display as. Okay, so all lines are straight. All lines are straight. So what kind of line is this? Horizontal line, right? Horizontal line. And so then when you hit enter, it comes up. So now we're getting into graphing here. If you start using this, like in terms of even for just computations, you'll start to realize this is so much more convenient than a handheld. And lots of my students who have been through different classes with me where we use GC, they just use this for everything. They don't use a handheld anymore. Okay, and I hope that that's your journey too. Okay, so y equals x squared is our favorite parabola, right? Okay, now of course you don't have to start a new line to do so. If I want to edit this now, so suppose I want to edit this, and now I want to make it 3x to the 5th plus x to the 4th. And again, so you're gonna, if it's not cube or square, you need the caret. So you need to do Control or Shift 6. That will give you and then minus, 4x cubed. Minus 7x squared plus 10x plus 1. All right, so I wanted something more interesting than that. Let's see if I can make it more interesting. What should we do here?
So you're
bigger.
and dragging on the map to change the window? Is that how you change the window?
Oh, yeah, so you can just, once you get in there, you can just grab it and move. Right. You have to, if you put the cursor onto the axes,
okay, there it is.
you'll get a hand, and then you can just drag and move it.
You use 2 fingers to move it.
Yeah. Let me try 8x cubed. Okay, that's a little better, but we need something more interesting here. Maybe 6x to the 5th. Okay, that's fine. Okay, so now suppose I've got this here, and I don't particularly like my view of it. So let me show you about zooming. So down in the lower left, you've got a zoom out and zoom in. The first one is zoom out. Oh, cool. Look, there's another little glitch on there. Nice. Okay, and then zoom in. But this is really not helping me show, say, this particular polynomial the way I want to show it. So what do I want to do? I'd really like to zoom out just on the y-axis. If I zoom out just on the y-axis, I want to be able to see there's another feature down here to this polynomial that's off the screen. But of course, I want to see the middle of it too. So on Mac, if you hit Option, you see that the little horizontal arrows come up. Now on PC, does anyone try Control? Try Control. What? Yeah. Horizontal? Okay, so Control on PC, Option on Mac gives horizontal bars. So now this will just zoom in and out on the horizontal axis. Command on Mac gives you vertical control of just the zooming just on the vertical axis. And what is that for PCs? It's probably the button Shift. Shift on Mac then gives you vertical control. So what do I want to do? I want to zoom out on just the, so I zoomed out twice just on the vertical axis, and this is a better kind of view for me for my particular component. And then I'm going to zoom in on the whole thing. And now I've got a view that I want of this. Everyone able to zoom in and on individual axes? You're able to zoom in and out on the horizontal, zoom in and out on the vertical.
Not vertically. Oh wait, it worked. It's magic.
You got to hold it down
Yeah.
as you're clicking.
Okay.
Is it working now?
Yeah, no.
Okay.
What do we do? Yeah, on a PC?
Shift is for vertical, the vertical axis. Just zooming in and out on the vertical axis. You got to hold it down when you use the buttons.
It's doing a bar. Oh, it's doing a bar.
Okay, and then for control on a PC, we'll do the horizontal zoom. Now, so I heard box zoom. You can also zoom in on a. Let's see, how do you do that? If you hit Shift, yeah. So if you hit Shift and then create a box, and then let go, it'll zoom in on the box. So hit Shift and then click and drag a box, and then it'll just zoom in on what you highlighted. So now I'm back to where I was. Okay, if you click on the curve, you get crosshairs, and it will show you crosshairs, and then up here in the upper left-hand corner of the window, it gives you the current coordinates of the point you're highlighting. And then you can grab on that, and then you can move it. And then as you move it, the coordinates of the points update to wherever the current location is. Just click on the. All you do is just go to the curve and just click on it. Now, got my sound down here. When you're doing that, it will, as you zoom, say on this red curve that I have this polynomial, it's going to knock at every intersection. So it knocked there and locked in on the intersection. Every root. So if I come down here like this, grab it again. You can do it. You can do it. I lost it. It'll knock on and lock in on the roots, the zeros, and then also the maxes and mins. And every time it does that, it's going to give you a very good approximation for those values of those locations. So on intersections, zeros, maxes and mins, if you drag those crosshairs, it'll lock in on those places and give you those coordinates or a close approximation. Yes, sir?
To customize it, to have it make a sound.
Maybe, is there a sound on the PC? No, it should just work. You got your volume up?
Oh, sorry. Yeah, I thought it was somebody else's.
Okay. Does it work on yours?
Good.
Okay. Yeah.
Is there a way to get the exact value and fractions value?
Fractions? I don't think in this, not when you're just dragging the crosshairs. This is all going to be decimal approximation. Other questions up to this point? How are we doing so far? So the two I've got, I guess it doesn't give you the y-intercept. It's a low point. So with this example, there's tons of knocks, right? Because there's lots of high points, low points, roots, and intersections. Okay, questions so far? Zooming. Just computing stuff. Basic graphs. Y equals. Okay, so let's watch videos. Everyone loves videos. Hopefully this one. Can you hear the sound back there?
This is it. This is what you've been working for.
This isn't a spoiler. Let's see if
I rented this place and I started bringing it here because I didn't know what else to do.
Volume.
Yeah.
Yeah, maybe it's better with just my
Is
computer.
there a remote? The remote has a volume
Does it? This is just the video camera.
There's a variety of temptations. How much is this?
He says, how much is this?
I have no earthly idea.
No earthly idea.
I truly don't. I just stack it up. Keep it dry, spray it for silverfish. There is more money here than we could spend in 10 lifetimes. I certainly can't launder it. Not with 100 car washes.
Okay, there's more money there than I could spend in 10 lifetimes, and certainly more than I could launder in 100 car washes. So, how much is it? So what I want us to do is I'm going to give you the dimensions of a bill, and I want you to write one command line on GC, one command line that estimates how much money that is, assuming that they're all $50 bills. Okay, assuming those are all $50 bills, I'll give you the dimension of the bill. I want you to write one command line that will make an estimate of how much money that is. Okay?
Wait, can we look at a different frame and see how many bills are?
No, I'm going to give you the dimension of a bill. I'm going to give you the dimension of a bill.
You know, the dimension of the box. We'll have to estimate.
So here's the dimensions of a bill. That's the So, using one command line, write an expression that will estimate how much money that is if we assume it's all $50 bills. And that's the dimensions of the bill and the big font down there.
Did you have it on the stack instead of being at the bottom of this one?
Then it's going to cover up the picture. I guess I can try. No, you need the picture too. There, is that better?
So the dimensions of the bill. So we're just gonna go.
Go. So do it. So let's see if we all get in the same ballpark. So see if we can all get in the same ballpark.
By 6. Oh yeah, we could estimate like how tall.
You can work together if you want. Work together. Work by yourself. Doesn't matter. Go.
So like that's I think my I see it 8 by 6. Versus by 8. I see. Let's divide by 8 to long. It looks like it's square. Well, it's not a square. Is it not? I mean, it could be an optical illusion the way it could be, and we could all do different things. I'm gonna simplify it to 6 by 6. Most of that yeah, So how about 6 by 6.
Like, is he tall? So first,
You know, the height, how many meters tall is one? Because we only know the metric system. Can we look up centimeters to
I'm about to write those up there.
okay.
Yep. I'm going to write up some conversions here in a sec.
Let's see the height.
Did you divide the surface that's your
Ooh. Okay, so maybe something that might be helpful. 1 inch is 2.54. Do it up here. And what else? 1 meter, 3.28 feet. Anything else you want to know? There's different approaches. Any other conversions you might want? You all know how many centimeters are in a meter, right? Anybody got a number yet?
No.
Just estimating. So don't get bogged down on perfection on your estimate.
So this is all determined on how big you estimate that.
Exactly. So I think the easiest thing to do is to estimate this in meters. Estimate these dimensions in meters because your bills are in centimeters. It doesn't matter. There's other ways to do it, but so I just estimated 2 by 1.5 by 0.75 meters. 2 long, 1.5 the short just dimension, and then like 3/4 tall. So then the volume would be in meters cubed. Would just be so. Okay, so that's the volume of our stack, if that's what you estimate. And what I'm going to divide by. Volume of 1 bill.
Yeah.
If you click on the dot, you have to click and pull it.
Okay, is this how many bills there are?
No.
Why not?
Because that's 70 centimeters.
Yeah, that's centimeters cubed, right? So I just divided meters cubed by centimeters cubed, right? That's not going to work, so I need the volume of a bill in meters cubed. So all these centimeters I'm going to convert to meters. Oops. Yeah, I want the meters cubed of 1 bill, right? The meters cubed of 1 bill. Agree? Does it make sense? So that's dimensions of a bill in meters, right? And then I multiply them together to get the volume of a bill in meters cubed. And so what did I just find? That's about how many bills there are then. So who said, so I got 100 million. So who said 90 million? You guys said? So our estimates were close on the size of the thing. So yeah, something upwards of some 50 to 100 million or 150 million, somewhere in there. Okay, any questions on that activity? Lots of ways to approach that, but what I like about this is rather than doing, remember, unit analysis is kind of really a brain off activity. It's just like put the things in the right place, get your units in the right place so that they cancel out, and you're never really thinking about what the operations of multiplication and division mean. So a nice thing about graphing calculators, you can have students set up these single expressions to do these conversions or calculations, and then you ask, you say, well, what does that thing in parentheses mean? What is the value of that? What does that mean? And then in this parentheses, what am I finding there? And then the whole fraction. What's that? The whole fraction. Say. And I could highlight that and just put another set of brackets. So it's really nice exercises for your students to have them construct single expressions that do these calculations, and then knowing what every part, what's the value of every part, the meaning of it. All right, let's do another one like this, but something more geometry here.
Is there a way to minimize the graph half of it after you've already graphed something?
You could just grab the top of it and then just slide it all the way down to the bottom, and it'll disappear if you want. All right, so here's a geometric figure, and it's saying using only the values in the diagram, 4, 5, and 9, and then if you want to use 2 as a multiplier, that's fine, and pi. Write one expression for the area of the region inside the trapezoid and outside the circle. Okay, so what's the total area inside the trapezoid and outside the circle? But here's the key. You can only use these values, 4, 5, 9, and then if you want a factor of 2 or a factor of a half, you can do that, 2 and pi. Okay, but don't. So let your expression do all the computing along the way. Okay, go. So this is.
We're not allowed to have
Four zeros, right? That 180. And when you have it just like it's displayed there, you should get $2,109.64. And what is that? That is, if you look down on the table below, that's the payment on a mortgage with a rate of 6%, a principal of $250,000 for 15 years, 180 months, and that's what you pay every month to pay off that loan, $2,109.64. Okay, everyone able to get in that expression? So then if we wanted a new loan, so look at the second row on that table. If you wanted a new loan, you could come back to this line. You could either copy and paste it into a new line, or you could just edit this one. So everyone find the payment on the next loan there, the second row in the table. Second row in the table. what's the payment on that? So that's an interest rate of 6.25, a payment of, or a principal of 480,000, and that's for 30 years, 360 months. You get that payment.
You have to change this one. After the 6, just like you did, because we're changing the rate.
So if we're like, if we have too many lines, can something that we do like 10 lines up affect what we're doing currently if we like define a variable?
Yes, the lines will have influence on each other, but we're not quite there yet, so just hold tight. I got 2955. So other people get that? So suppose does everyone get this for the second row in the table, the payment of 2955, or if not, is there a question? Everyone good? So if we want to keep finding out the payments for these different loan scenarios, how's that feel in terms of efficiency? Right? So this is like, we get very tedious very fast. Even with this really nice display, changing all those numbers every time, not efficient. Okay? So we want to evoke graphing calculators' ability to have formulas and use formulas. Okay. So before we do that, let's turn the page. Look at this box up here. There are certain symbols that are reserved for special functions in GC. So as we're picking letters to be our parameters and variables, we want to make sure we avoid the ones that are already built in, have a function, right? So x and y, we talked about that, are reserved for the x and y axes. So, and then prompt GC to graph. Z is reserved for a z-axis, so for 3D graphs. Okay, R, theta, and phi are for polar, spherical, and cylindrical coordinates. Okay, so I'm going to stay away from those. T is reserved for a parametric variable, like in Calc 2 and Calc 3 when you had parametric and vector functions. So that's T. U and V are similarly, they're parameters for vector functions of 2 parameters. E, pi, and I, we already saw E and pi. I has the value negative square root of negative 1. And then N, which we'll see later, when you use lowercase n, it will activate a slider where you can manually change the value of n. Don't worry about that now. We'll work on it later. Any other characters are fair game, just open variables, so you can define them and use them. So, for instance, if we go back here, we can leave those, but I'm going to come here and I'm going to define capital R. So capital R equals right there in the middle of the page, 0.0625. Let's just go ahead and do, and then a new line. We'll just go ahead and do the example, the second example that we did there. P was, well, no, let's do the example on the page. So 260,000. And capital N equals 360. Okay, and then we're going to define a formula of these values. So we could use, we've already used capital P. So not only can you use single letters, this is a really key point I'm about to make. So everyone tune into me because this is always a question I get over and over and over again. How do you do this? So let's see if we can As many people as possible can get this the first try. You can make a variable out of a string of letters. Okay? So because we've already used P for the principal and we want some kind of variable for payment, let's use PMT. Those three characters together will be the single variable for payment. Okay? So to do that, you're going to hit backslash, which is the one above your enter key. It leans back to the left. Then type capital P, MT, and then when you hit backslash again, you'll see that they disappear, and now that PMT is a single variable. Those three characters together. And then any other line that you write, if you write this capital PMT without the backslashes, it'll know, and it will make it that single variable. So what is it again? You're going to surround a character list by backslashes, which is that character above the enter, and that will create a variable made out of a string of characters. And so for this one, so we could define that as a value. I could say payment equals 1,000. That's fine. Okay, but in this case, I'm going to use it to define the formula, and that formula is R divided by 12 times P times 1 over, this is the same thing we did before, 1 minus parentheses, 1 plus R over 12, all to the negative n. Capital N, make sure you have capital N. Do I have it right? So now notice if I make a new command line and I type I don't need the backslashes now because that PMT is already defined as that single variable. If I just type capital P MT, it will tell me the value according to the formula that I put in the previous line. And that's according to the values of R, P, and N that I put in the previous lines as well. So the way that so R, P, N, and payment are all the same thing. They're just parameters. I've defined them. I'm defining R to be this value. I'm defining P to be this value, and I'm defining payment to be this value, whatever that computes to be. So I'm using all four of those exactly the same. It's just one. Three of them I'm specifying a value. The other I'm specifying as a formula. So now look, let's go back to the previous example. What do we have? We had 6.0625, and what was our principal? 480,000. So all I have to do is come up here and change the principal to 480,000. And as I'm doing that, now the payment just updated to that value we got before when we did it by hand. Do you see that? So all I have to do now is go to those R, P, and N lines and just change the numbers in R, P, and N. Payment will update automatically because it's set at that formula. Question over here.
So you said you did the PMT because you had already used P
Huh?
to stand for payment?
Yeah.
Why didn't you just choose a different variable?
I could.
Okay.
Yeah. Yeah, so this is nice because I know exactly what it is, right? Yeah, I could have used capital X, I could have used capital H, little h, anything I wanted. But I wanted to show you how to use a string, and then this is a nice choice because we look at it, we know exactly what it is, payments, right? Payment. Question, yeah?
When you make variables, do you have to differentiate between lower and uppercase letters?
It does. It treats those differently.
Okay.
So you can use uppercase X. It's a free variable. Lowercase x is going to be the graphing one for the horizontal axis. But uppercase X is a free variable to use. So you can use lowercase h and uppercase h, and they'll be separate. Other questions? So which way do you want to fill out the table? Do you want to fill it out using method 1 on the first page, or do you want to fill out the table using this way? Right? So this is a lot easier. All you got to do now is just change R, change P, change N, and then payment automatically calculates according to the formula we gave it.
I have a question.
Please.
So if you set up a whole thing like you did for payment, and it's like this whole thing, and then you put in equals, can you make it so that it's like you put in, I don't know, like D, like a variable you have to use, and we'll give it to you in terms of that variable?
No.
Can you do that?
If I put a capital D into that formula, and I haven't defined what D is, it will default, the D value will be 1. So for instance, if I if I just add 1 here, so if I add plus D, and I haven't defined what D is, look what it did. What did it think D was? 1. So now it's 2956. So if you use a variable and you haven't defined it, it's going to take it as 1. Other questions? These are good questions. Other questions?
Can you say your decimal places?
Yes. So if you go to File, Document Settings, Significant Digits. So say if I knew I was in the thousands and I wanted dollars and cents, I could do 6. So you can change the precision, the significant digits. Okay, so let me give you I got 3 minutes left. Let's give the game plan here for what's coming up for Thursday. Any questions on this blue worksheets? So you have let's just find it here. Okay, so something very similar to this is going to be in your assignments very soon, like in the next 15 minutes. So I'm going, this link here is to a file whose first 2 pages are the ones I gave you in blue. Pages 3 and 4 are going to be what you do for homework on Thursday. And then all the instructions are here. So part of this, you're going to, just follow through pages 3 and 4. Just follow the instructions exactly as they're laid out. Let me draw your attention to this part right here. Part of this finishing 3 and 4 is going to be you're going to be creating some graphs, and then you're going to save those files, and you're going to submit them to me electronically. So for those graphs, okay, you're going to use what I posted here, the visual and what I posted. You're going to make sure you have a color view of this. Use the electronic file posted above to get an accurate image of the graphs you're reproducing on pages 5 and 6. Here we go. Listen. For full credit, what you submit must be exactly the same as what you see in that file. Exactly the same in every way. Your files must look identical to the images I'm providing you on pages 5 and 6. Did I make my point? Yes. So, if I come back to you and say, look, this is different, don't say to me, oh, I didn't know you meant that. I mean everything. I mean every single detail of the images I give you. You're going to produce it exactly the same way. There's no detail that I don't care about. Does that make sense? Because I want to see that you can do that. That you know in GC how to manipulate factor X or factor Y or factor Z, whatever those are. Okay. So I mean every detail, everything. It's got to look exactly the same. If something doesn't look exactly the same, it's not full credit. Okay. Yeah. Questions?
Thursday's not the 27th.
Yeah, I know. This is you're gonna.
Okay.
Don't worry. Sorry. I know. This is okay. And then this is the instructions I'm submitting. Okay, I'm going to send an email out to you. So normally the email will go out like the night before, like Wednesday evening. You're going to reply to the email, and you're going to name your files exactly like this. And please reply to my email. Don't start a new email. So reply to my email without changing the subject line, so that I get it all in the same conversation. Don't start a new email. Don't change the subject line. Just reply to the one that I send, and these are the instructions for naming your files. And then you also have the critical précis of the first reading. Did you get my email about the updated explanation? It's a really good page. Not only does it explain exactly what the critical précis is, but It tells you why they're so valuable. Okay, it's a really valuable exercise, and it kind of gives you some insight into that. Okay. So, critical phrase C, hard copy, due Thursday, along with replying to my email with these GC files. Yes?